here. And you know what? I'm going to get through this. Last two characteristics, and we'll take a break. Okay, corrosive. Layman's terms. Federal. I'm going to do federal. And your book has both. Federal. It's a liquid. It's aqueous. The pH is at or below 2, or at or above 12.5. Okay? Or, it's a liquid. It's aqueous. This is federal. And if you put it into contact with mild steel, it will dissolve 6.35 millimeters, which is the equivalent of a quarter of an inch. If you repeatedly applied it, drip, 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 it's going to dissolve a quarter inch of steel in the air. I'm a large quantity generator. I got 90 days. So if you send it to a lab, you can take a representative sample of mica, which is mild steel, that's a thin wafer, and they can dissolve it for, I think it's like 72 or 96 hours, and they can look at it and think, oh, yeah, it'll dissolve if it starts to score it. But if it dissolves 6.35 millimeters, it's a quarter of an inch in a year upon repeated application, or the pH is at or below 2, or at or above 12.5, it's considered corrosive. Federal. Is everybody with me? Okay, state no difference. But the state also goes on to state also if it's non-aqueous. So first of all, what's aqueous? Yeah, it has water. Yeah. So what's non-aqueous? Doesn't have water. Could be a liquid that's organic, or it could be a solid that's dry, that doesn't have water. So federally, it has to be aqueous. And then you check pH or the corrosion of mild steel. California says, well, we got an idea. Take a representative sample, equivalent weight, add water to it. Then check the pH, and then check the relative rate of corrosion. So California pulls a lot of things into the regulatory arena that otherwise aren't subject to the federal criteria because they're non-aqueous. Sodium hydroxide, red double dye, Drano, crystal Drano, okay? Sodium hydroxide. Crystal Drano, go to get rid of it, it's not a hazardous waste federally under RCRA at my facility because it's not a hazardous waste because it's not aqueous, even though it has a high pH. California says, dissolve it in water, and you pH it, and it comes out to be 14. It's a hazardous waste. California, it's a non-RCRA hazardous waste. It's corrosive, but it's not subject to the federal criteria according to that specific waste corrosivity criteria. Clear as mud? We're good? Any questions? Fundamental difference, okay? Then we have definition of reactive. Reactive wastes are somewhat subjective. I'll read through this real fast, give you a couple examples. Unstable, undergoes violent change without detonation. Probably a lot of your organic peroxides. And those are typically refrigerated or frozen. Those are oxidizers. NFPA, you would see the reactivity portion, which is the yellow signage portion 3-4 listed. But there are 5.2 DOT materials. But those are reactive. Reacts violently with water. Okay, that would be lithium, potassium, sodium, cesium, franconium. Those are radioactive. But it's something that doesn't like water. It's water-reactive metals. All your 4.3 flammable solids that are dangerous from wet, when you go to dispose of those, or if they exhibit that characteristic for DOT, would also be considered reactive waste under both EPA and DOT and DTSC. And the definition of reactive waste federally and the definition of reactive waste in the state of California, there is no difference. They're the same. So it's captured by one, it's captured by the other. Generates toxic gases, vapors, or fumes with water. Okay? What's that? Okay? There's one case history federally, not in California that I'm aware of, where if you take a waste that you produce and you mix it with water, and the resulting vapor or fume or gas, probably fume or vapor, is above the PEL for listed chemical, that's toxic. It's hazardous waste. Okay? And that's kind of captured in that cyanide and sulfide-bearing waste compound. Because later on we go on to say that, yeah, if it's a cyanide or a sulfide-bearing waste, and you mix it with water, where the concentration of that material comes into contact with something above 2 but below 12.5, but it produces hydrogen cyanide or hydrogen sulfide, that's considered to be a hazardous waste. Or it's capable of detonation or explosive. Those are your hazard class 1.2, 1.3, 1.4, 1.1. Readily capable of detonation or explosion or decomposition reaction standard temperature and pressure. Those are your organic peroxides. Or it's a forbidden explosive. Oh, okay. It's not a definitive criteria. It's kind of subjective. I think this is reactive. Sodium hydroxide. It really doesn't like water. Ready? Sulfuric acid concentrated is called oleum. And oleum is an oxidizing acid. There's oxygen in that acid. Nitric acid. Fuming nitric acid, HNO3, has oxygen that it can evolve and give off when it reacts. And so these concentrated acids are considered to be water reactive. When you add water to an acid, it's extremely reactive. So it's not uncommon for a waste to be, you ready? Check this out. Nitric acid is reactive because it doesn't get along with water. It's like the Hatfields and McCoys. It's corrosive, it has pH of 0. So it's reactive, it's D03. It's corrosive, it's D002. And it's an oxidizer by DOT standards, it's a D001. So I can have a waste that I produce, fuming nitric acid, that is both ignitable and corrosive and reactive. Oh, okay, all three are captured. Well, once it's captured under RCRA, it's a RCRA hazardous waste. But I would have to use all of the appropriate characteristic codes when I go to dispose of it. So to properly classify it, to properly characterize it, I'd have to apply all three. We're good? Yeah. Yeah. Well, I said before 5. That's any time between now and 5. Okay. All right. Are we okay with this? RCRA, reactive, non-RCRA, reactive, same, no difference. This is like the definition of an ignitable waste. There is virtually no difference between the state and the federal. California, DTSC, CUPA enforcement, federal, US EPA, no difference. Okay. The toxicity is where there is a demarcation. There's a fairly substantial, I'll call it a delineation, state-federal. Federally, RCRA, you have 8 inorganic compounds, I'll call them metals, and then you have 32 organic compounds for a total of 40 chemicals for which we've established a regulatory threshold called TCLP, where if that chemical or component is in my waste stream, at that threshold, after I subject it to a test methodology that emulates the disposition in a landfill if I bury it, that makes it a hazardous waste. Turns out that methodology that was actually developed to determine if it's a hazardous waste, which is called TCLP, is an acronym for the Toxicity Characteristic Leachate Procedure, where basically, in layman's terms, it emulates the disposition of hazardous waste if you bury it. So if I take waste, put it in the ground, let it bury, or I bury it in the ground, then what happens is it going to move? Is it going to create a problem to an off-site target, surface, subsurface? So what essentially was accomplished federally under RCRA is they took and they tried to emulate the conditions in a landfill because this test method came from the LDR program back in 85, 86. And what they said was, hey, if you bury waste, what's the chance of it moving, migrating? If it's restricted, when can I not restrict it? When can I actually bury it? So when they came up with this procedure, it emulates the disposition of the material when you put it in the ground. And federally they say, well, probably some of it's going to dissolve. So they dissolve it in a mild acid. Federally, they use acetic acid, they use vinegar. And then they say, well, some of it's going to dissolve. So you don't use a strong acid, you use a weak acid. And then when it starts to migrate, it's going to bind generally through ionic bonds, through potentiation in the ground, so it becomes locked in the soil and it just basically stays in the substrate and it doesn't migrate. So they have determined that roughly 1 out of 20%, actually 5%, 1/20th, will migrate. So you dilute it. So you test it, you dissolve it, then you dilute it, and then you calculate what is the disposition of this stuff I've buried in the ground. Well, that's where TCLP came from. And when we talk about TCLP, that procedure is essentially trying to emulate the conditions that exist in the ground. So if something's buried, we can determine whether or not there is any possibility or possible issues with off-site environmental targets. That's TCLP. It predicts the fate in the landfill. Okay. Well, non-RCRA. And I'm going to come back to it in a minute. Actually, let's go back to it right now. In your book, in your handout, if you turn in your handout past the California presumptive wastes, you come to a table. It says a brief comparison of California and federal classification schemes. And what this is a summary of what I've presented and what I'm about to present, and then a summary of all of that put together. This is a summary of the differences between state and federal. I'll probably come back to this right before the end of the class. Flip that over. I will come back to this at the very end of the class. Skip it. Because this is essentially how it's written in our regulations. So if you want to know how to classify a waste, this is kind of the fail-safe chart. You can go through this, yes, no, and you'll get the right answer. It may not be easy to answer yes or no, but this is the chart that actually is codified in Title 22. On the next page, this is what I'm going through right now. Talk about waste that exhibit a characteristic of ignitability, corrosivity, reactivity. And then if you flip over, you'll come to a chart that is on Table 1, no page number, that is for RCRA only regulatory thresholds. And it says the maximum concentration of contaminants for the toxicity characteristic. Okay, these are your 40 RCRA chemicals that have regulatory thresholds under RCRA that make it a RCRA toxic waste. If it's a RCRA toxic waste, it is a RCRA toxic waste because one of these chemicals or more is at or above its regulatory threshold. This is the test right here. This is it. Actually, these are the chemicals that are listed. Plus, it lists the waste code. And in the far right-hand margin, it lists the regulatory threshold. Since this is an extraction, it's in milligrams per liter. Extraction, milligrams per liter. 40 chemicals. 8 are metals. 32 are organic compounds. And the metals are D04 through D011. D012, if I find it, starts the organics. Indrin, okay, there you go. All right, so any questions with this? This is RCRA. I have a waste that has 2,4,5-triphenolxacetic acid, 2,4,5-T. Okay, look at this. I have 2,4,5-TP, it's also called Silvex. I can look that up because I can look up the chemical abstract CAS number. Same chemical, same number. The regulatory threshold is 1 milligram per liter. Now, that's not 1 milligram per liter in the waste. That's 1 milligram per liter once I subject it to a specific test method where I extract it, then I dilute it after I've digested it, and then I calculate the resultant diluent after I've extracted it from the waste. I.e., after I figure out its fate in a landfill. Yeah? So it's not a total. It's a soluble. It's a TCLP. Okay. We're good? We're good? 5% of you are good. 10% of you, I think I got it. 20% of you are, yeah, I think I heard that before. 40% of you are, let's see, what time is it dinner tonight? And 20% of you is, what time can I get home? No questions. Yeah, question. Great question. Great question. You do anything you want. Yeah. I mean, you really can. Yeah. Okay. If it's a solid, let's say it's a soil, contaminated soil, the typical guidance put out, and I kind of subscribe to it because it makes sense, is if you're going to run it for metals, federally you got 8. Cam metals, you got 17. So you're going to do a cam metal screen. Because if you look at the record metals, let's say none of them are in there, you could have another 9 metals that are regulated by the state of California that would not be even looked at if you're looking at a metal screen that's driven by RECRA. And those actually, the cam metals is on the next page. It's on next facing page. There's your metals. So what typically is advised, typically, we're jumping a little ahead, but great question, is you run your totals for the metals. And when you run your total, you're digesting the entire metal. And when you digest the entire metal, if the metal's there, the nitric acid used to dissolve it's going to pull it out. And if it's there, we'll see it. If it's not there, we won't see it. CAM 17 will first run the total, and then it will run the STLC if requested. And the lab knows when to run the STLC based on the concentration for the TTLC. No, it's a test. It's a test. STLC is a test. TTLC is a test. Yeah, both tests. The wet test, 2 tests. T-clip, 1 test. So what's typically subscribed to or advised is run your wet test totals. Do the CAM 17, the totals. And when you go to the totals, and I think this is on a slide that comes up here in about 4 or 5 slides. When you run the totals, you're basically telling the lab, don't know what's there, but digest it all, quantify it, and tell me. That's the total. That's the TTLC. So I don't care if it's soluble or non-soluble. I'm going to digest it using nitric acid in a concentrated media, and if there's a metal present, I'm going to digest it out. And then I'm going to quantify it. And when I do the totals, I'm actually doing it milligrams per kilogram, which is the equivalent of parts per million. And so if that metal's there, I'll see it. And that's the total. And it's pretty simple. Do you have a lot of it there? That's what the total is going to say. Yes, I do. No, I don't. What I don't know, when I look at the totals, I do not know if that metal, which is present, is going to be in a soluble state and it's going to move, or it's in a non-soluble state and it's not a big concern. Don't know that. All the total tells me is the metal's there and how much. What T-clip does federally, and what the other state test called STLC does, California, is it says, okay, I know there's a metal there, but if the metal's there, is there a likelihood it's going to become mobile and move in the substrate because when there's water or hydropressure applied to the ground, the soil, the landfill, and the like, it's going to migrate. And so I want to digest the metals that are there in my sample using a mild acid. And here's where there's a difference between the federal T-clip and the state STLC. Okay? Same process. They digest it in a mild acid. Federally, they use vinegar. We'll call it acetic acid. In California, we use citric acid. Turns out citric acid, it is used in the test methodology under SW 846 is the state specifies citric acid because of all the citric fruit we used to have. We're going back 35 years ago. Okay? And federally, we're going to digest it with the vinegar for 24 hours. California, we're going to digest those metals with our citric acid from fruit, citrus, for 48 hours. So California uses a different acid, a little more concentrated. We digest it twice as long. Federally, under TCLP, we use vinegar. We digest it half as long with a weaker acid. And then when we extract a certain amount of metal that has been dissolved in the vinegar, you're going to dilute it. And it's going to be diluted 20 to 1. So they've decided only 5% of my metal is going to migrate in the soil. That's TCLP. That's federal. California says, like the idea. Let's digest it using citric acid, 48 hours, more concentrated, and we're going to dilute it 10 to 1. 10 to 1. Okay? So the California process of determining waste hazardous waste using STLC is more aggressive. It's going to pull more of it out of solution. It's going to digest it longer, and you're going to dilute it twice, half as much. They're not the same. Look at the metals. Look on those 2 pages. Look at lead, look at mercury, look at chromium. They're the same numbers. The STLC state method, the federal TCLP method, have the same numbers. Lead's regulated as a hazardous waste under TCLP at 5 milligrams per 5 milligrams per liter. Look at the STLC for lead in the state. It's 5 milligrams per liter. Mercury, I don't know mercury. Is it 0.5? 0.2? Federally, it's 0.2. Okay? They're all the same. So people will have their waste analyzed, and they'll do the TCLP, and if it's captured, well, then it's a hazardous waste in California because it fails the TTLC, or it could fail the STLC. If it's done federally and we do the TCLP result, TCLP, federal, TCLP, RCRA, TCLP, it fails that, then it's a hazardous waste federally. The values are the same. The methods are very different. So if it fails the state method, and it's going to fail the state wet test STLC method long before it fails the federal. Because the state's method is more aggressive, pulls more out, you dilute it less as much, captures more metals. We're looking at 17 metals. Federally, we're looking at 8 metals. So the state's process of determining whether waste is hazardous is a lot more aggressive, number one. Number two, you ready? If I want to have my waste, which is contaminated soil, determined to be hazardous, not hazardous, what you ought to do, consider, is run totals. Run it for CAM 17. And when they run the CAM 17, it's going to run all 17 metals, state and federal. And it's digesting everything. And if the metals that are determined with the CAM 17 total, so you're doing a total, you're doing a TTLC. I'm doing a total. How much metal's there? If that result that you get is 10 times or more the value of the STLC, then you better run the STLC because the dilution factor is 10 to 1. And if all the metal that is present soluble, it's all going to come out. And when it all comes out, you can dilute 10 to 1. But if I run my total value and the result that I get is less than 10 times my STLC, it would never be captured. It would not be a hazardous waste. Not state. And not federal. Because federally, it's a 20 to 1 dilution, and it's a weaker acid, and they digest it not as long. So if I want to know whether or not I have a potential issue, I need to run the totals for all 17 CAMs. And dependent upon the result that I get when I run the the totals, and which means I'm checking for the soluble amount of that metal, I'm checking for the non-soluble portion of that metal, and I'm adding them together, and that's my total. And if that result is below 10 times the STLC value or 20 times the TCLP value, game over. I don't need to do anything. I'm done. Not a hazardous waste. Not a hazardous waste. Where we end up caught in the quandary is when it's more than 10 times the STLC value or more than 20 times the TCLP value. Because then you better run this and you better run that. This is going to be captured first. The state's soluble threshold is going to capture the metal first because it's most aggressive. It might not be captured over here because either it's not one of the 8 RCRA metals, it's something that's regulated by California, nickel, not federally, or when I run it, it's captured here, and say it's chromium or mercury, it might be captured using this method. Well, if it gets captured over here, then I have to decide, is it captured federally? I know it's captured over here. It's one of the 8 metals federally under RCRA. I might need to run the RCRA criteria. That's TCLP. But if I run the RCRA criteria to determine is it captured or not captured, and it's captured, you have a RCRA waste. Yep, RCRA waste. And when I go to dispose of it, which eventually is our ultimate goal in most instances, I give no credibility to the state program. Psst, doesn't exist. How that waste is disposed of is governed solely under the LDR requirements under HISWA under RCRA. In other words, it's managed as a federal waste. Any state land disposal requirements on state waste doesn't apply. Off the radar. Doesn't exist. How you dispose of that waste in California, it's governed solely by LDR requirements because it's federal waste. Question? Yeah, I know, it's a lot. And wait till it gets complicated.
Do you have a sample that captured by the STLC, but not by the TCLP?
That's very possible. I have a sample. It's a soil captured by the STLC, state. I run the TCLP, right? Not captured. Then you have a California non-RCRA hazardous waste. I give it a California waste code number. Yeah, there is no federal number. I don't give it a federal number. It's not a RCRA waste. It's a California waste. This is actually pretty common with soils. This is not uncommon. This isn't an anomaly. This is a regular occurrence. A lot of soils that are contaminated with metals, whether they're indigenous or from a spill or an episodic event, a lot of those wastes end up being non-RCRA because they don't have the amount of the metal to make it a RCRA hazardous waste under TCLP. Oh, well, time out. What? 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 Playoffs? Do you have to do it? Let's go back to my comment about an hour and a half ago. Are you required to sample? Huh? Required to test? Generate knowledge. Generate knowledge. Yeah. Don't know. Not certain. Then you're generally forced to do it by the receiving facility through the profile process is one option. You are required to do it if they're going to give it an approval number because their permit may require a mandate, a representative sample, and analysis accompany it for determining whether or not they can accept it. That's probably where we're going to get captured and have to do it. They don't. Sometimes they don't. It depends on what facility I use. Then I'm a CUPA, and I work for San Joaquin, Sacramento, Solano, Contra Costa, San Bernardino, Riverside. Maybe I'm leaving some of you guys out. And I come to your facility, I'm probably going to encourage you to have me take a representative sample. I may split it and aliquot it. I'm going to give you half, and I'm going to take half. And then my budget is kind of appetite, so I'm going to encourage you to test it. And then send me a copy of the test results. And I'll just keep the copy off the sample to the side so I can validate whatever you get if I don't believe you. And I think you're an honest guy. I mean, you have a beard and you're kind of old, but so am I, and I'm old. But I don't have a beard, but we're honest, right? We're honest people. So I'll encourage you to take a sample, send it to a lab, send me the results. So I'm going to have you provide me some analytical on this one incident called the grab sample to establish or determine hazardous, non-hazardous. Comes back borderline, okay? And you and I and the regulatory agency and state, DTSC and CalEPL knows that the 80% regulatory threshold in SW 846 generally is established with 3 or 4 samples. So I may come back again and say, let's do it again. Have you sample it, have you aliquot it, or we'll do it together, send it off to the lab, so it's on your nickels, I don't pay for it, and then get the results back, send it to me, and wow, it's borderline. Now, how borderline is it? We can determine statistically how many samples I need. But to establish an 80% confidence, so I can either say this is a non-compliant or you are compliant, I'm going to need 4 samples. So I'll do this 4 times. I can do it 4 times same day, 4 different days, 4 different weeks, any frequency. I don't need to do that, but if I'm going to challenge your determination, not hazardous, to establish an 80% confidence that it is, it's going to require probably 4 samples on my behalf. I can do it less than 4. If it's so far not or so far that it is, I don't need 4. I can do it with 1. I can do it 2. But if it's borderline, I may need 4, 6, 8, 10, 12 samples. But eventually, I'll determine with an 80% confidence that it is or isn't. And what happens is, if federally, it's federal, which side's federal? This side's federal? Federally, if by chance it comes back in its borderline state for a metal, borderline, right there, lead, 5 milligrams, right? Lead's 4, 4.9, 5.7, 3.9, 4.2, borderline. I know that I don't even have to worry about T-clip. Why? But I don't have to worry about T-clip. Yeah. Less aggressive acid. I digested half as much, 24 hours instead of 48. And I dilute it twice as much. So the reality is, if it's borderline here, I know I don't have to run T-clip. It's off the radar. If it's captured here, and it's captured just above the regulatory threshold, I also know I don't have to run T-clip. Because it's, once I dilute it twice as much, it's going to be half as much. It's not going to be captured. Now, that's for those cases where it's pretty much definitive. However, it's 6 or 7 milligrams. Well, half that's 3, and so the digestion process using different acids, it's not 1-to-1. So when you get a little bit above half or 1.5 times, then you might have to consider running federal T-clip because the acids are different. But if a metal in soil is going to be captured, it will always be captured by the STLC first, long before it would ever be captured federally under T-clip. We're good? We're good?
Yeah. I mean, I run before I have to sort of samples and
Yeah, because there's a number of instances where if you have them run T-clip, it won't fail. It'll pass. So it's not a rec or hazardous waste, but it would fail wet test. It would fail STLC. Yeah, and TTLC, who knows? Because I don't know if it's soluble or not. Yeah. The lab's already got this figured out. If you send a sample to a lab, it's soil for metals, they're going to run total. When you ask them for CAM 17, they're running total. And when half of the wet, yes, half the wet. The wet is 2 tests. Total, TTLC, soluble, STLC. So when I send it to a lab and ask for a CAM 17 screen, they're running total. And from that, I can determine, you can determine, an inspector can determine, industry can determine whether or not I need to run STLC or TCLP, TCLP. But run total first. Always run total, 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 total. And what happens is, it's possible when you run your total, you get a metal that's above the TTLC threshold. It's not common, but you might. Well, game over. It's a hazardous waste. However, what type of hazardous waste is it if it fails the TTLC? Non-RCRA, because that's a non-RCRA criteria. Okay, then the question is, will it fail TCLP? Well, figure out your 8 metals and find out if any of those thresholds are 20 times or more the total value. I need an example. Look at your book. Let me tell you 2 more things, then we'll do an example. Okay, ready? I'm talking about solids that are digested, aren't I? I'm talking about dirt with metals. You with me? It's a liquid. It's a liquid. It passed the paint filter test. It's liquid. It's aqueous. It's got a pH of 2. And in that is some metals. No digestion. No dilution. They're going to run that metal for that liquid. They're going to give you a result. That result they give you is the total, which also happens to be the soluble, which is the TCLP. Okay? If it's a liquid and it's a metal that I'm testing for in the liquid, the total's the soluble's the TCLP. They're all the same. They're all the same. Because we don't have to digest it and dilute it, because if it's contaminated with water, it's going to migrate. It already is in an aqueous media. It has a direct vector for causing and disruption and polluting the environment. So if it's a liquid and it's aqueous, the total is the soluble, and the soluble is the TCLP. So if it's a liquid, and I actually send it to a lab, and I ask for a CAM metals, and it's a liquid, it's game over. They're going to run totals, and that's TCLP, and that's STLC. It's the solids where we get into the digestion and the difference. But for liquids, the total is the soluble, is the TCLP, is the TCLP. It's all the same. So then, when I compare things, I'll compare it to both regulatory thresholds, state, federal, because that is calculated in milligrams per liter. And if I look at the regulatory threshold, and it's above that, both state and federal, you have a federal waste. It's subject to regulations federally, under LDR, under HISWA, federally. Question? If it's a liquid, they're giving you totals, which is the soluble, which is the TCLP. If it's a solid and they're digesting it, then the results they give you back, they'll do probably total first, and when they give you a CAM 17 screen, they're going to give you all the totals. And they're going to highlight, it's an asterisk. Look at your next analytical. There's going to be asterisks on those chemicals that are above 10 times or 20 times the TCLP or STLC. And a reference back, yeah, it's based in milligrams per kilogram. It's milligrams of the constituent for the kilogram of the sample itself, the body. Yeah, so it's weight to weight. Yeah, for solids, it's weight to weight. It's milligrams per liter. It's based on milligrams weight per liter of the diluent, of the liquid they use. It's a diluted number. Yes, and an STLC gives you the result after they dilute it based on that test method. Yeah, and T-clip to do the same thing. That's correct. Does anybody else have a question? If anybody else has a question, go ahead.
No metals, but it's still high in other things like organics, diesel, or other hydrocarbons. Is that still reference?
Not so far. It might be listed. Maybe not. Maybe. And hydrocarbons, diesel, gasoline. We got benzene. We got a D code for benzene, right? So. But chances are probably not. You're looking at dealing with probably more like a non-RCRA or a designated waste. Probably not a RCRA. Could be. Probably not. I'm a betting man. I'm betting on non-RCRA.
Well, I'm killing fish. Right?
You're, well, any PETA representatives? You're not killing fish.
Right.
You're performing a test method that is prescribed under the Clean Water Act, adopted by NPDES permits, that the state thought, great idea, and they adopted that. But yes, you're using organisms to determine toxicity according, right, that's correct. Right. Yeah, that's still on RCRA, yeah. Yeah, to get it into the RCRA scheme of things, to get it to RCRA, well, I haven't talked about listed yet. But for toxicity, corrosivity, ignitability, or reactivity, no, we're off the screen. Unless it fails benzene. And it might fail benzene. Probably not. Yeah, diesel probably not. Any other questions? Clarifier sludge. Yes. Look. Well, nope, there's no gray. There's no gray. There is no gray. If it drips, take a 5 cc sample, roughly 5 milligrams, 5 milliliters of liquid, 5 milligrams solid, in a paint filter. And if you go down to Standard Brands and buy a paint filter, there are 70 micron mesh paint filter that's strained before I spray paint on. It's a standard size, 70 microns. And you take a representative sample of that sludge, you say clarifier sludge? Clarifier sludge. In the paint filter, representative sample. Make a slurry, because that's it. Unless I separate the liquids from the solids that naturally occur. But let's say I don't, I make a slurry. Take that, put it in the paint filter. Is there a drip? Is there a drip? Does it drip? It drips. It drips in 3 minutes. Has to drip in 5 minutes, 78 degrees, 1 atmosphere. Check that against flash point. That liquid would be ignitable. That would probably not. That's not. When I test a sludge, you ready? The lab centrifuges it. It aliquots the liquids from the solids. It extracts the solid, the contaminant from the solids using total, T-clip, or STLC, and adds that to the result for the liquids that are independently tested, and the combined result of what's in the solid and the liquid phase is then reported to the lab, from the lab to the generator. So if my waste is a sludge and I'm going to handle it as a representative sample, or that waste is a representative waste stream, they're going to centrifuge it. They're going to aliquot the liquids and solids, test them independently. The liquids, they're just going to test for the concentration of that contaminant, and that's it. Solids, they're going to digest it, and then they're going to add it back to the result for the liquids. That's the result. So that's how they deal with the sludges. That result is that's my total. Well, they can do it for soluble too. Yeah. They can do it for soluble. For the solid phase, they can do it. Because that's going to be less potentially than what it would be digested and added to the liquid. But the liquid, the soluble is a soluble, the soluble is a T-clip. But for the solid phase, if you want the total, they're both added. If you want the soluble, then you actually have to look at the STLC and the T-clip added to that value. No, there's the 9 additional California. Okay, see this page right here? It's page number X. Here, give me your book. Do you have notes in here? I'll give it back to you. Okay, here. Here you go. Okay, on this particular page, these are the federal metals. There are eight of them are in there. That's 40. 8 of those 40 chemicals are federal metals. Is everybody with me? And I can read them off to you. Arsenic, barium, cadmium, chromium, lead, mercury, selenium, silver. That's it. Those are 8 federal metals. Okay, and then your question was what? What was your question?
You said that some California product credits be tested, some federal does not.
Okay. Those are the 8 federal metals. Okay, on this page. I'm going to read them again. Arsenic, barium, cadmium, chromium, lead, mercury, selenium, silver. Those are the federal metals. Go to the next page. It looks like this. Okay, California also regulates antimony, beryllium, cobalt, copper, molybdenum, nickel, thallium, vanadium, and zinc. And those metals, along with all the other federal metals, make up the CAM 17. Okay, any other questions? Questions are good. Questions? Going once? Going, yes. You know what? There is probably half of us in here are confused, but you were bold enough to ask a question to help, and those people are saying, oh, I hope it's what I'm thinking. You have, I'm sorry, I missed that.
I had a prior understanding. I thought I knew.
Okay. Okay.
So let's have a liquid. It's primarily liquid. And I wanted to know what to do with
Okay.
So I run the metal. I run the total.
It's a liquid? Okay, when you run the total, you're done. You're done. Because the total, when a liquid has metals dissolved in the liquid and you run the liquid for metals, you're done. Because the total is the soluble, is the T-clip, is the STLC, is the TTLC. So if it's a liquid and you're running it for metal, when you run that test for the metal, there's no digestion, there's no dilution. You're just figuring out how much metal is already dissolved in the water. And that is the total, that is the soluble, that is the T-clip. So I compare that value to all 3 of these values. And where it will end up being captured first is either going to be under the federal T-clip criteria or under the state wet test under STLC. The TTLC value is so high, it'll be captured first either under STLC or T-clip.
How do I know?
Okay.
So
Okay. Ask another question. Okay.
So I get the results back.
Yes.
And, obviously they're below the TTLC.
Okay. Yeah. Right. Right.
So that basically tells me it's not enough.
If it's below the TTLC, okay. Look in the book. Look in the book. Look on that other page. Look on this page right here. Look on this page. It's below the TTLC. Okay. Okay. The TTLC values normally are roughly 100 times greater than the STLC values. So it's below the TTLC value. Okay? So look at the STLC value. Is the concentration that they've determined in the lab above the STLC? And if it is, it's a hazardous waste. Now, I'll tell you where everybody gets tripped up, including myself. The difference is, if it's a liquid, when they send it to a lab to have it analyzed and they give you back the result, it doesn't matter what they call it. They can call it milligrams per kilogram, it'll be milligrams per liter. That is the total, that is the soluble, that is the T-clip, that's the result. You compare that against all three of these values. The STLC, the TTLC, and the T-clip for a metal. Because it's soluble and because it's in solution and it's suspended in an aqueous media, that is the total. That's how much is suspended because it's a liquid. It's a liquid. The difference is if it's a solid and it's soil, whoa, wait a minute, time out. Now we go to using vinegar or citric acid, and then we dissolve it, and then we digest it, and then we dilute it, and then we check it. So soils, it's a different scenario, right? Different scenario. Now I can run the total first for soils. And that will not be the same as the STLC or the T-clip. It might be if everything is non-digestible and I can only digest it because it's non-soluble then it's the same value. Or all my digestible TTLC value is soluble. But it's still going to be diluted. It's still going to be, right. That's the fundamental difference. The difference is if I've got a drum of dirt and I want to know, is it hazardous waste? To make life easier for you, in about 20 minutes, there's a chart. If you follow the chart, we're done. Game over. This is it. And this is the chart. Follow this chart. Yeah, we're not quite there because I haven't talked about list of waste yet. Yeah. Okay, we're good? Any other questions? Okay.